clap now because at the end you might be like, that was a waste of time. Okay, so my name is Leif Madsen. I'm going to be talking about 5 things you may or may not know that Asterisk could do. These are things that I think are pretty cool and aren't necessarily, either have other talks specifically about them, might be something you don't necessarily know Asterisk can do, or maybe knew that it existed but didn't know kind of how it worked or what kinds of features it provided and things like that. So I'm just going to go through some things that I think are pretty neat. So again, I'm Leif Madsen, co-author of Asterisk, the Future of Telephony with Jim Van Megelen and Jared Smith. Also working on an updated version, which is based on Asterisk 1.8, which is called Asterisk, the Definitive Guide. We're shooting for March of 2011, and excuse me, you can go to ofps.o'reilly.com. We're testing some new software for O'Reilly, which is essentially like review board for Asterisk, but for books. So you can help us review the book kind of as we're writing it. Again, it'll be released on Creative Commons and all that good stuff. I'm an Asterisk bug marshal and release manager, so I essentially go through and kind of triage the issues on the issue tracker and help get Asterisk releases out to the community. And I have a fair number of years of experience using Asterisk since about 2002 when I went to school. So some of the things I'm going to cover in this presentation, LDAP integration, which does exist in 1.6.2, but is something I've just recently been starting to use, and I think is actually pretty neat. Google Voice and Google Talk, which has been updated by David Vossel to work in Asterisk 1.8. The calendar integration, which was started last year and is in 1.8 now and has been updated since the last time I presented about calendar integration, so I'm going to talk about that a bit. Distributed device state with XMPP. It's a way of getting the blinky lamps on your phones across multiple servers in a cluster, which can be physically located across the internet. Prior to 1.8, we could use OpenAIS, but that's not meant for across the internet. And a neat little feature called pitch shift, which probably isn't really all that useful, but I think it's just kind of neat, and I want to talk about it. Let's see, so LDAP integration, like I said, available in 1.6.2, but maybe not well known. I had known about it, but hadn't been using it, and with a lot of experience, it actually works. I've been heavily testing it over the last couple of weeks, because I've had a couple clients that are interested in getting LDAP integration through Asterisk, which provides a real-time interface just like a database. Some of the advantages are going to be that you can centralize your Asterisk users and have that along with your logins for other systems. So you can give users login information and they can use it in multiple locations, including your Asterisk. I've been testing with OpenLDAP, but I'll be testing with Active Directory fairly shortly. So, Google Voice and Talk allows you to accept calls into your Asterisk system via Google Talk, which is the web-based client you'll see in your Gmail, and also Google Voice, which is the free PSTN interconnect system that Google's developed and allows US people to use. The other cool thing is you could integrate that along with Jabber Send and Jabber Receive to both send messages to your Asterisk system and then have Asterisk receive a response from that where you could redirect those calls based on the XMPP message. And this is all just integrated with Google. You don't have to necessarily use Google for the Jabber and all that, but I think it's kind of neat to tie in with all those Google services, which are free and work fairly well, and to utilize that in your Asterisk system. The calendar integration allows you to hook your Asterisk into your calendaring system, whether that's through Google Calendar, MS Exchange, or Zimbra. There's various formats with Exchange and CalDAV and iCalendar. You can then use that information to route calls through your availability. So if I'm busy, there's no point in ringing my cell phone and my desk phone and all that stuff. I can just automatically send my voicemail by setting up a period of time that I don't want to be available. I can control that. Maybe I don't want to accept calls on the weekend or something. I just set my whole weekend as busy. Or maybe I have a big meeting or I'm going to be out for the day. Set it on my phone, which then syncs up to my calendar, and then all of a sudden it controls whether I'm available via phone or not. The other cool thing, which I'll talk about, is basically using it to call participants and drop them into a conference. So you can either use it as a wake-up call system or the ability to call everyone who's part of a conference you've set up and put them all in the conference at the same time without people having to remember. Distributed device state with XMPP is a method of distributing the device state across systems, and by using XMPP, it allows you to run it over something other than a LAN. So that was developed by Marquis42, I think Brad Watkins. And I think it's a really neat feature. It uses the Tegace XMPP server because it's using pub sub nodes and stuff like that, which is just an implementation detail, but essentially that's the one server that this will work with ideally support in the future going forward to use it against other servers. The pitch shift function is a neat little function that David wrote in his spare time, which essentially just allows you to modify your voice up and down. I wasn't even going to put this in here until we were sitting down yesterday trying to come up with an actual business case usage, and I kind of came up with one. So I'll talk about that, and I'll have a little demo of what it sounds like and all that, ideally with assuming I have time. So LDAP. I started with using the instructions on the Ubuntu documentation site, which essentially got me started to get kind of the framework installed. Beyond that, then I started using the contrib scripts asterisk.ldif file. And after about 3 days of importing and trying to figure out why I was getting errors and stuff, I realized that this file was different than another file that comes with Asterisk because it depends on whether you're importing the schema into the LDAP database or whether you're using a slightly older version where it just reads all that from a file. So the one where you just copy the file in was updated, but the other one was out of date. And after 3 days, I finally figured out that they're not the same file. Updated it, got that patched, and put it into Asterisk. So now I have like no errors and everything's working great. The way that this is done is essentially you take your existing schema that's all imported and you essentially extend it using an object class called asterisk SIP user. There's various other object classes like for EEX and for the configuration file, essentially all the other real-time stuff. But the one I've been working with is asterisk SIP user, and it's just easy enough to use that as an example. So the key files for that are going to be res_ldap.conf, which is going to control how you're mapping the fields that Asterisk expects to the LDAP database. And then we have extconfig.conf, which is the file we use for Asterisk real-time. And then we're controlling what the backend is that we're using for connection. So whether that's LDAP in this case, ODBC, I think curl might be one of them, but there's a few others that you can use in that file. So here's the simple configuration that I have been using. I have the URL line here where I essentially control what IP address I'm connecting to, the protocol version, the base DN, which is just essentially my domain name. So the domain being shift8.org gets translated into that. The user, the administrative user that we're connecting to the LDAP database in order to authenticate. I've created an admin user, and the password I've set as Canada. Then under the SIP header there, this is where we're doing our mappings. So we have name equals CN, where the CN is essentially the person's authentication name in the LDAP server. You could change this to UID, or you can make an entirely separate field if you wanted to have it separate from that person's username. And then caller ID is an example, and we see we mapped it to the asked account caller ID field in the LDAP database. There's a whole bunch of fields there, which is fairly large, and then we've just defined the object class for this particular filter, which is asterisk SIP user. And then this is what our extconfig.conf file is going to look like. We've defined the SIP users and SIP peers to be loaded from LDAP through the object unit of users within the shift8.org domain. And then we see at the end is SIP, which is what's referencing this SIP word in the square braces. So calendar integration. It does require libiCalDev and libneon.dev, -dev. On CentOS, that's the command that I use to install it. You have to use the EPEL repositories, which is an external repository outside, basically by the Fedora people. And then Ubuntu, it's fairly straightforward. You just install it through apt-get. Uses the calendar.conf file, so we can define multiple calendars within this file if we want. This one in particular is attaching to my Google Calendar. And so the type we've set to CalDAV, the URL, which is the Google Calendar location. the slash on the end is significant. You need to make sure that's there. We've defined our user and our password to log in. This is not my real password. And the refresh time is how often to update, so how often to pull the calendar server to get new information. And the time frame is how much information we're going to pull within that frame. So I'm basically looking at the next 60 minutes and pulling all that information into memory. And then in 15 minutes later, I'm going to grab another 60-minute block and throw that into memory, which will be essentially 15 minutes longer than where I was just at prior. So we can set that to however long. I mean, 60 minutes is probably not really necessary, but I mean, anything longer than that's definitely not necessary for the most part, unless you're on such a connection that you want to just update it once a day or something, and you can't update it any more often than that, or maybe you have a lot of calendars and you have to change how often you're refreshing. But obviously you want to have the refresh time ideally in a reasonable amount of time, because if you set something for a meeting in 10 minutes, I mean, my refresh time is 15 minutes, and I need to, you're going to have a sync issue there. So with the Google Calendar integration, we can trigger calls to devices when events are starting. I've set it up to essentially set up as a reminder of a meeting that I maybe wasn't aware of, or maybe I'm not at my desk, or maybe I leave my desk a lot and I set something up 20 minutes before lunch, and I decide to go have an early lunch, and now 10 minutes later I'm supposed to have a meeting that I'm not thinking about. So you just call me, or like we write documentation at 7 in the morning, which is 6 a.m. for Russell, and this is sometimes useful to get me out of bed. So this is fairly simple. Once you've set up the calendar section, you just have to add these 3 lines. So the channel that we're going to call, which is, say, my desk phone, and once that channel is answered, the application I'm going to use and what data I'm going to pass to that application. So in this case, it's the playback application, which is playing the sound file. This is your wake-up call. So that's essentially what it looks like there with the information added. And here's a very simple dial plan that I've set up. So we can change this. I really have these slides backwards, but what we can do is, instead of playing a file, we can execute some dial plan. So I've changed, you see the channel, same channel that I'm calling is essentially my desk phone. And then the context is the automated meeting setup context, and the extension that's being executed is the start extension. So here's our context. We have the start extension. We essentially are just grabbing, using the calendar _ event dial plan function, the location. So this is just a field within the Google Calendar that I've just written some text in, which is essentially the device identifier. So